You please share your index number through chat. So I will take attendance now. Within 1 minute period. මිනිත්තුවක් ඇතුළත දාන්න ඔයාලගේ ඉන්ඩෙක්ස් නම්බර් ටික chat එකට මම attendance ගන්නවා දැන්. Again, end of the lecture, I will take attendance. Okay. අන්තිමට ගන්න. 48 students here. කාට හරි පුළුවන් නේද lecture එක record කරගන්න? Oh. Okay, thank you, sir. Sankar. So we will start. So last week we discussed about standard parts, no? Standard parts and so different annotations. Okay. Different notation in drawings, general notations. Okay. So you know every machine elements include the technical drawing that show its geometry. Okay. So we can understand about geometry specifications using these drawings. Okay. So drawing is very important thing. So in this drawing, you use standard notations and symbols. Okay. So actually, this is very important for engineering field. Okay. So we discussed about common notations, different notations. නේ අපි මේවා ගැන කතා කරන number of fours ඔයාලා identify කරගන්න පුළුවන් මෙන්න මේ වගේ notation එකකින් නේ 4 by 5.375. Okay, 4 mean a number of circles and 0.375 mean diameter of the circle. Right? Circle එකේ diameter එක මේ holes ගන්න. ඒ වගේ ඔයාලා drawing වල notations දාන්න. So here we discussed about the counter walk, counter sync, spot pace. Okay, so we can use these symbols, different symbols. Okay, different symbols for identify these items. Okay, here you can see a hole, and we discussed what is keyway and key seat. Okay, keyway, key seat, and a key. Okay, so here you can see a key. This is keyway. This is the key seat. Okay, and slot, chamfer. Here you can see a groove. Okay, this is the groove. Then today, so we stop here. So I will continue from this slide. Okay. So basically, we are dealing with standard notations and specifications. Okay. Okay. So here you can see our main topic is bolts, nuts, and screw. We are dealing with bolts, nuts, and screws. Okay. So this is very common fastening elements in mechanical design. Ne? Nut and bolts අපි හැම වෙලේම මේක ගොඩක් වෙලාවට හැම මැෂින් එකකම දකින්නෝනේ. මොන හරි කම්පවුන්ඩ්ස් දෙකක් හෝ තුනක් ඒ වගේ කනෙක්ට් කරගන්න තුනක් හරි ඊට වඩා හරි කනෙක්ට් කරගන්න අපි දකිනවා මෙන්න මේ joining method එක. නැත්නම් fastening method එක. Okay. So they are standardized mainly by thread dimensions and pitch, you know. Okay, so we can standardize these bolts, nut, screws. Okay, so according to thread dimensions and pitch. Okay, නේ අපි thread එකේ තියෙන thread එකේ තියෙන dimensions එකයි ඒකේ pitch එකයි අරගෙන තමයි ඒ කියන්නේ thread එකේ diameter එක inner diameter එක sorry minor diameter major diameter ඊළඟ pitch diameter මේවා අනුව pitch එක ඒ අනුව තමයි අපි මේවායි standard අඳුරගන්නේ නේ ඔය දැක්කන් table එකේ so according to the standard tables we can get standard values okay so here you can see a series classification so you know some of classifications we discussed about fine series and coarse series am I correct අපි කතා කරන්නේ coarse series fine series so actually here you can see a series classification okay so this classification uh, this thread series uh, are determined by the pitch and the measure diameter of the thread okay so depend on pitch and measure diameter then uh, uh, then here you can see a series coarse series fine series extra fine series okay so we can classify series core series you know core series as what has fewer threads per inch okay less thread okay එක අඟලක පොඩි threads ප්‍රමාණයක් තියෙනවා නම් ඒක තමයි core series okay so then fine series when we come to fine series more threads per inch has more threads per inch. Threads per inch we can indicate using TPI. TPI means threads per inch. Okay, threads per inch. So core series used for quick assembly. Okay, it's very easy to assembly process and disassembly process. Okay, so used for actually this core series used for quick assembly and disassembly process. So suitable for cast iron, soft materials, soft metals and plastics. Okay, we can manufacture using these materials. Okay, core series. Then fine series, when we come to fine series, use when greater clamping force is needed. Okay, so fine series use when greater clamping forces is needed, common in precision assembly and assemblies and application needed tight joints. Okay. So commonly core series we can write as a UNC standard notation. As a standard notation, core series we can write as a UNC. Okay, please remember that. So fine series we can write as a UNF. හරි. එතකොට core series කියලා ඔයාලා notation එකක් කොහේ හරි UNC කියලා තිබ්බොත් ඒක core series එකක් කියලා තමයි ඔයාලා identify කරගන්නේ. So according to this UNC notation, you can identify this is a core series. හරි. UNC කොහේ හරි දැක්කොත් තිබ්බොත් core series කියලා identify කරගන්න. UNF කියලා තිබ්බොත් කොහේ හරි fine series එක මේක fine series කියලා identify කරගන්න පුළුවන්. හරි. So and finally you have extra fine series. What is this? In this case has very fine threads. Okay, so many a lot of thread per inch. Okay, so this extra fine series used when engagement length is short but the load or stress is high. Okay, so this is used for some aerospace applications and sometime used for high stress applications. Okay, so so actually always we can select these standard series based on material type, pitch and major diameter and assembly disassembly conditions and also strength. Okay, so these are key items. Always select according to a material type of material. Okay, uh, strength, required strength, then assembly disassembly condition, assembly disassembly condition. Okay, so according to these requirements we can select thread series. Okay, so basically we can consider these requirements. Then here you can see series. Okay. So you know general rule for thread direction. Okay. So if the thread direction is not specified in drawings, it is always assumed to be right hand threads. Okay. Here you can see a right hand threads. කොයි හරි drawing එක series drawing එක ඔයාලට දීලා තියෙනවා නම් sorry දීලා නැත්තම් මේක right මේක right hand හරි left hand හරි කියලා ඒ කියන්නේ R H O L H කියලා එහෙනම් මොකද්ද මේක we assume හැම වෙලේම අපි assume කරනවා මේක right hand thread එකක් කියලා okay okay so actual right hand you know right hand one this means the bolt or screw tightens when turn clockwise හරි ඔරලෝසුවේ කටු කැරකෙන පැත්තට ටයිට් වෙනවා නම් තද වෙනවා නම් ඒක මොකද්ද right hand thread okay so you can use right hand rule for identify direction so a ball threads into a tapered hole should be turned clockwise so a ball thread into a tapered hole should always be turned clockwise to time. Okay, this is the standard direction for most mechanical fasteners. Okay, this is the standard one. So special cases in some applications torque or rotation so left hand threads in some applications torque or rotation might loosen the right hand threads in such cases left hand threads are used these um, tighten anti-clockwise okay so these actually used for special cases හරි මේවා use කරන්නේ special cases okay some we can see in some rotating machineries so you know we can see this left hand threads in our bicycle pedal okay so sometime used in automotive components okay this is used for special cases left hand threads we can indicate this left hand threads using LH නේ අපිට මේක හඳුන්වන්න පුළුවන් LH වලින් පෙන්වන්න පුළුවන් LH කියලා left hand thread යන LH කියලා අපිට indicate කරන්න පුළුවන් then so commonly I told you when left hand threads are used the drawing will clearly show us LH okay left hand thread so right hand thread RH okay so in some drawing as example you can see M10 1.5 LH what's the meaning of this notation we can see this type of notations in our drawings what's the meaning M mean what M කියන්නේ මොකද්ද 10 multiplied by 1.5 LH මොනවාද මේ Yeah, 10 mean diameter. Major or minor? Minor diameter, major diameter, pitch diameter. So you know you have now you have idea. Yeah, major diameter, 10 mean major diameter, 1.5 mean pitch diameter, LH mean left hand one. Okay, this thread is left hand thread. හරි මේ thread එක left hand thread එකක් තමයි LH කියන්නේ. Okay. So actually, always you need to check thread direction on drawing before assembly your machine or machine parts. Okay. හරිද? left hand right hand කියලා ඔයාලා drawing එකෙන් identify කරගන්න ඕනේ. ඔයාලා high කරන්න කලින් මොකක් හරි machine එකක් හරි මොනවා හරි high කරන්න කලින් හැම වෙලේම බලන්න ඕනේ මේක direction එක. Okay. So actually, if you complete incorrect way, okay, so it can case to fail your machine. Okay, it may be damaged during operation. Ne? That's the issue. So in thread forms, we can see multiple threads. Okay, single and multiple thread forms. Here you can see uh, here you can see a drawing. There are different type of thread forms. Okay. So here you can see single threads, double thread form, mm, triple thread form, double square thread form, triple ACME. Likewise, we can see different type of threads. Okay, according the form. Then if the type of thread is not mentioned in a drawing, it is assumed to be single thread. Okay, this is the first condition. ඔයාලා drawing එකේ දීලා නැත්නම් මොකක් හරි thread type එක double law single law ඒ වගේ හැම වෙලේම අපි ගාව අපි identify කරගන්නේ assume කරන්නේ පළවෙනි එක single thread එකක් කියලා. හරි single form thread form එක single. Okay. So actually single means single thread means has one continuous ridge wound around the cylinder in a helical form. Okay, it's called single thread. Okay, for a single thread, lead equal to the pitch. So you have idea about lead. So we discussed about this lead under terminology part. We discuss කරන්නේ lead කියන්නේ මොකක්ද කියලා. What is lead? Give me an answer. You can unmute and tell. What is lead? Anybody? මොකද්ද lead කියන්නේ? For a single thread, lead equal to pitch. What is this lead? Lead කියන්නේ මොකක්ද? So please give me your answers. දෙන්න බලන්න උත්තර. So distance between two adjacent threads. It's called pitch. Distance between two adjacent threads mean pitch. Yeah. 360ක් කැරකෙනකොට යන දුර. Oh. So you can imagine like this. You have a ball, thread ball, and have a nut here. Okay. So you can move this nut. Okay. You can move this nut. So we can say a distance a nut moves in one revolution. It's called lead. මේ නට් එක revolution එක වටයක් කරකවනකොට යන distance එක දුර. ඒක තමයි lead එක කියන්නේ. Okay. So in a single threads lead equal to pitch. එතකොට pitch එකේ දුර ඒ කියන්නේ අර thread දෙකක් අතර තියෙන දුර සමාන වෙනවා අරයා ගමන් කරන දුරට. lead එකට. නට් එක ගිය දුරට සමාන වෙනවා අර thread එක අතර දුර. හරි? පැහැදිලිද? පටල ගන්න එපා ඔක ඕනි වෙනවා. ඒ කියන්නේ ඔයාලට. ඒක මම පැහැදිලි කරලා කියන්නේ. හරි? So in industry these type of single threads are the most common type. Okay. ගොඩක් වෙලාවට දකින්න තියෙන මේ single thread කියන එක තමයි. ඒ pitch එකේ lead එකයි සමාන වෙන ඒවා තමයි. Okay. So then multi-threads have two or more ridges running side by side. Then have two or more ridges running side by side on the same cylinder. Okay. So double thread have two ridges. Triple thread have three ridges. Okay. In these cases, we can get lead. We can get number of threads multiplied by pitch. Okay. So if you have uh, so here first one second one you can see B this drawing. This one is double thread form. Okay. So pitch is P, but lead is 2P. Okay. Likewise, we can get lead number of threads multiplied by pitch. Okay. Then Uh, then the slope line is the hypotenuse of the right triangle was short side equal 0.5 p 0.5 p, okay, 0.5 p for single thread and p for double and 1.5 p for triple threads. So the slope line uh, of the thread is the we can get for single thread short side equals 0.5 p pitch. P mean pitch, okay, 0.5 multiplied by pitch. Then for double thread equal pitch. For triple thread short side 1.5 multiplied by p, okay. Okay. Then so multiple threads are required when small rotation mass gives faster moments at low required power. So uh, actually multiple threads use when a small rotation mass produce faster linear movements. So this example is good toothpaste cap. So we need to suddenly remove this cap. Immediately we want to we need to remove. Okay, some bottle lids we need to release immediately. Okay, it should consist with the quick release mechanism. නේ? එහෙම mechanism යන්නේ අපිට ඕනි දැන් toothpaste එක අරගෙන ටක් ගාලා අරගන්න එපා. අන්න ඒ වගේ වැඩ multiple threads තමයි use වෙන්නේ. Okay. So commonly we can say single thread is very high strength one and simplicity is very easy to manufacture. Okay. And multiple threads very speed and speed in motion. Okay. And efficiency. We can say like this. All right. So here also you can see pitch and lead. In first one is single thread. Pitch should be equal to lead. Second one, which type of one? Double threaded screw. Okay. Double threaded screw. Lead should be equal number of thread multiplied by pitch 2p. Okay. Number of pitch. Sorry, number of threads. එතකොට double threaded කිව්වහම thread දෙකක් යනවා. එක ඔයා මේ නට් එකක් දාලා එක වටයක් කරකැවුවොත් ඉස්සරහට ගිහිලා තියෙනවා pitch දෙකක්. හරි? pitch දෙකක් කැරකිලා ඉස්සරහට ගිහිලා තියෙනවා. තුන්වෙනි එකට නට්ටයක් දාලා කරකැවුවොත් pitch තුනක් ඉස්සරහට ගිහිල්ලා තියෙනවා. pitch එක වගේ තුන් ගුණයක් යනවා lead එක. අංශක 360ක් කරකැවුවාම pitch එක වගේ තුන් ගුණයක් ඉස්සරහට ගිහිල්ලා තියෙනවා. හරි? So here you can see a standard symbol. Okay, thread symbols. So we have different representation styles depending on level of detail needed. Okay, so as these are mainly detailed, simplified according to requirements. Okay. So here you can see standard time. Okay, uh, external detail threads. First image. So we can give this type of detailed representation. Second one, internal detail thread. So internal one. Here we can give this type of elevations for internal one. Okay. So this is like a ball. This is like a nut, internal one. Okay. So usually in a detail representation usually applied for a measure diameter greater than 1 inch. 1 inch since it looks more realistic and clear. Okay. So external and internal detail threads are shown in figure A and B here. So these are most common methods used in engineering drawings. So you have seen this type of drawings. Then so here you can see a simplified drawing, schematic drawing. Okay. Then this simplified drawing, the common method. Actually, then we can see this type of methods in our drawings. Okay. So threads threads are shown using two parallel lines like this. Okay. So easily understand about this thread and schematic diagram, schematic representation use mainly metric threads. Okay. So combine simplicity with enough information for identifications. You can see M20 multiplied by 2.5. We can easily identify about our thread using this schematic one. So these two are most common one. Okay. Simplified representation and schematic representation. So generally use this one and this one. හරි මේ drawing දෙක තමයි සාමාන්‍යයෙන් use වෙන්නේ. මේවත් use වෙනවා. මේ වගේ drawing උත් තියෙනවා. Basically use වෙන්නේ මේවා තමයි. And also then we can categorize our nut and bolt according to the fit. Okay, class of fit. Here you can see different categories, class of fit. Okay. So actually, this class of fit defines how tightly or loosely a ball fits into nut nut or thread. Okay, nut or threaded hole. Okay, so actually we can identify tight or loose. Okay, වෝල්ට් එක අර වෝල්ට් එකට නට් එක දානකොට ඔයාලට පේනවනේ පොඩි ක්ලියරන්ස් එකක් හරියට හරියට තද වෙනවද නැත්නම් චුට්ටක් හෙලවෙනවා වගේද අන්න ඒක අනුව තමයි මේ ක්ලාස් බෙදලා තියෙන්නේ. Okay, so it these classes of it ensure proper function of our proper functions proper function assembly, okay, of our nut and bolt. Okay, so actually clearance මේ ක්ලියරන්ස් එක හොඳට ෆන්ක්ෂන් වෙනවද මේක අපේ ෆන්ක්ෂන් එකත් එක තමයි ඇත්තටම බලපාන්නේ ෆන්ක්ෂන් එකයි ඇසෙම්බලි කරන ඇසෙම්බලි එකටයි ඒවට තමයි මේ ක්ලාස් ෆිට් කියන එක බලපාන්නේ. Okay, so here you can see classes are represented by numbers 1, 2, 3. Okay, and also letters A and B. Okay, so A mean actually external threads. Okay, B mean internal threads. Okay, please remember A mean external threads, B mean internal threads. Okay, so here first one is class 1 A and B. So this is a loose fit where quick assembly is required and play between part is acceptable. So use where quickly assembly and disassembly are important. Okay, assembly and disassembly are important. So allow in this case class 1A 1B allow some small play. Okay, small clearance between two parts nut and bolt. හරි මේ nut and bolt එකේ පොඩි clearance එකක් allow කරනවා මෙන්න මේ class 1A 1A නම් external thread එක 1B නම් internal thread එක. Okay, so this class 1A 1B is suitable for temporary corrections. Okay, temporary දේවල් වලට temporary connections වලට තමයි temporary assemblies වලට තමයි so we can use for temporary assemblies temporary connections සම්බන්ධතා වලට තමයි අපි මේ assemble කරන්න තමයි ගන්නෙ මෙන්න මේ පළවෙනි එක මතක තියාගන්න ටිකක් temporary assemble වලට වගේ තමයි ගන්න body clearance එකක් තියෙන එක. And then second one is class 2A, 2B, a high quality general purpose commercial class of fit for bolts, nuts and screws used in mass production. So this is most common one, commonly used in commercial applications, commercial fit, then provides a good balance between easy assembly and tightness. Okay, so this type of class 2A, 2B, 2A mean external thread, 2B mean internal threads. Okay, so this is basically used for mass produce. Uh, so used in mass produce bolt nuts and screws. Okay, then class 3A, 3B, this is close fit. Okay, so this is actually loose fit. We can say as a loose loose fit. හරි මේකට කියනවා loose fit එක. class 2 and 2B general purpose fit. Here you can see. General purpose මේක තමයි ගොඩක් වෙලාවට use වෙන්නේ. mass production විදියට කරනවා මේවා. class 2A 2B කියන එක. ඇයි general purpose යන්නේ? එතකොට මේ class 2A 2B කියන එක general හැම එකටම පොදුවේ use වෙනා වගේ තියෙන bolt nut and bolt තමයි මේ. එතකොට ඒක හැම වෙලේම use වෙන ඉන්න mass production එක. ලොකු production එකක් කරන්න පුළුවන්. Then when we come to class 3A 3B it's called close fit. What is meaning of close fit? Actually, close fit means tight fit with minimum clearance. හරි. ගොඩක් හොඳට fit වෙනවා නට් එක බෝල්ට් එක හොඳට fit වෙනවා. චූටිවත් clearance එකක් නැති තරමට තමයි අඩුම clearance එකක් තියෙන විදිහට තමයි fit කරන්නේ. Okay. This is very useful for high precision assemblies. So then commonly used for in instruments, aerospace. Okay, so this type of thread we can see in our micrometer screw gauge. හරි micrometer screw gauge එකේ තියෙන class 3 ඒ විදිහේ thread එකක්. හරි ඒක smooth යන්න ඕනේ instrument එක. Okay, then so according to class of fit we can categorize these type of classes: class 1A 1B 2A 2B 3A 3B. Okay, then here you can see a standard drawing. What is this? I'll ask few questions. What is this drawing? Is this internal thread or external thread? First one, first image, first drawing. Is this internal one or external thread? What is the type of thread? මේක internal thread එකක්ද external එකක්ද? Yeah, this is the internal thread. This is the internal thread. Here you can see a general notation. So first number indicate major diameter of the thread 0.5. Second one thread per inch. UNC mean UNC mean what? Means Unified National Course. This thread is course type thread. Right? Course type එකක් තමයි මේ thread එක. Course series thread. Okay. This will indicate series. Okay. So then class of fit 3B. Okay. 3B. 3B mean B mean internal thread. 3 mean class. Class 3B. Okay. Likewise, we can understand. This second image, this one is external thread. So same procedure we can follow. 0.25 mean mesh diameter, 20 mean threads per inch. Okay, UNC mean course series. Okay, Unified National Course UNC. So UNC meaning of UNC you can identify using this box. Okay. So UNC mean Unified National Course, UNF mean Unified National Fine Series, UNEF means Unified Extra Fine Series, UN mean Uniform Pitch Series. Okay, likewise we can see a different type of threads. Okay, so then 2A mean class of fit. 2A mean class of fit. Okay. So according to the letter A, you can identify type of thread. This is external one, external thread. And LH mean left hand thread. හරි මේ වගේ notations වලින් අපිට identify කරගන්න තියෙනවා. ඔයාලා කියන ඔයාලා drawing අඳිද්දි මේ වගේ notations හම්බුණාද? Have you seen this type of notations in your uh, drawing subject, manual drawings? දැකලා තියෙනවද ඒකෙදි? So in so you know this isometric system. Okay, this representation you know. So M mean isometric metric meaning we can indicate M. Okay, so this M indicating metric thread. නේ ඔයාලා දන්නවනේ M කියන්නේ metric thread කියන එක. මේක තමයි indicate කරන්නේ. This is a basic representation format. හරි මේක මූලිකවම තියෙන එකනේ M කියන්නේ නේ. So nominal size in millimeter given in millimeters. So nominal size mean measure diameter of the thread. අර වගුව මතකනේ measure diameter of the thread. Okay, then pitch size you can you know about pitch. Okay, you can get using millimeters. So this pitch mean distance between two adjacent thread pitch or roots නේ thread දෙක අතර දුරනේ කොහොම මොනවා හරි point දෙක thread දෙක උඩ point දෙකක් අතර crest එක හරි roots එක හරි root හරි ඒවා මොනවා හරි අතර තියෙන දුර තමයි pitch එක. You know about pitch. Pitch size we can get using millimeters. Okay, so general purpose tolerance, a tolerance class that included tolerance position and a tolerance grade for both pitch diameter and minor diameter. So as example we can write M20 multiplied by 2.5. You know, M mean metric thread. Okay, according to this letter M, we can say this is the metric thread. M තියනවා නම් අපි කියනවා metric thread එකක් කියලා. ඒ කියන්නේ millimeters එක තමයි ගනුදෙනු කරන්නේ. inches නෙමෙයි millimeters. හරි? So this is a isometric thread. Then isometric thread. Then measure diameter is 20 millimeter. Nominal diameter. Pitch is 2.5. Okay. So ISO threads are specify general purpose of tolerance. Okay. So the tolerance include both position and grade. Okay. Then pitch diameter actually control thread fit. Okay. Minor diameter control thread depth and clearance. Then here you can see a drawing. First image is internal thread. Second one is external thread. Okay. So here you can see a notation like this. Metric multiplied by 24 mean diameter, nominal diameter of the thread, 2 mean pitch. Second one also say M25, 25 mean external diameter, then 2 mean pitch. Okay, these are very simple, no? So here you can see some metric thread system, both tolerance and grades included, positions. Okay, tolerance positions defined. Okay, so and also these included accuracy and fit. Okay, so actually these determine how tight or loose the connection will be between mating threads. Okay, so you can see some tolerant grades here. GH, simple EGH. Likewise, we can see tolerant grades. Sorry, tolerant positions. So tolerant grades we can indicate using numbers. Grade 4, 6, 8 likewise. So grade 4 is the most accurate one. Grade 8 is the least less accurate. Okay. So so lower grade number equal tighter tolerance, higher precision. Okay. Then tolerance position define the location of the tolerance zone relative to the basic size. It provides allowances. Allowances mean clearance. Okay, for internal threads we can see capital G and H. Okay, G mean is small allowances, small clearance, light clearance. Okay, so H mean no allowances. Capital H mean no allowances, no clearance. Okay, fit it may be fit tightly. හරි, තදින්ම තදට අර හිතට තද මේවා වෙනවා නම් තදට සෙට් වෙනවා නම් මේට් වෙනවා නම් ඒකට අපි පොසිෂන් එක ගන්න H. G ගන්නවා නම් small allowance එකක් තමයි තියෙන්නේ. Okay. So when we come to external threads, so you can see simple EGH. Okay, E mean large allowance, more clearance. Large allowance mean more clearance, and position G mean small allowances. Okay, position simple H mean no allowance. It's a very tight fit. Right. අදට high වෙන එක තමයි no allowances කියලා. Right. So here you can see general notations. M6 1 multiplied by 4, sorry, M6 multiplied by 1, 4H 5H. So this matrix, the symbol is metric, then this is nominal diameter, pitch, okay. Tolerance grade indicate by 4, then tolerance position H, okay. Then tolerance minor diameter tolerance 5, grade H, okay. This is indicate pitch diameter tolerance, this one minor diameter tolerance. So same procedure we can follow for external threads. We can identify about external threads. Okay. Then here you can see some isometric thread tolerances, internal and external sizes. You can see here. Okay. 864 mean grade. Capital HG mean oceans. Okay. It indicates precision levels. Okay. Tighter and more precision the thread. So tolerance positions indicate using capital H, capital G, simple G, F, E, likewise. We can see. Okay. Indicate internal threads, simple letters for external threads. Here you can see some standard table. Here you can see a standard table. Here, first column is isometric thread designation. It's mean so you can indicate M2 multiplied by 1.5 likewise. Okay, this is our thread type. Okay, so we can get pitch value, tolerance. Okay, 6G mean, what is 6G? 6 mean grade, G mean our position. Okay, 6G. Then measure diameter you can get maximum value and minimum value, pitch diameter maximum and minimum value, minor diameter. Okay, this is the standard table. හරි. ඒතකොට ඔයාලට M 1.6 කියන එක 1.6 multiply by 0.35. Major diameter එක 1.6. ඔයාලා කට් කරද්දි මේක මැනුෆැක්චර් කරද්දි මෙන්න මේ procedure එකට follow කර හැකියි. If you have to manufacture this type of M6, M1.6 multiplied by 0.35 nut, sorry, bolt, you can follow this procedure. Okay. So in this case, measure diameter should be between 1.581 from should be between 1.581 and 1.496. Okay. So pitch diameter should be 1.354 and 1.291. Minor diameter should be 1.202 and 1.75. මේ දෙක අතර එන්නවා. හරි? ඒ වගේ ඔයාලට මේක බලලා manufacture කරන්න පුළුවන්. Okay, so this is the end of bolt, nut and thread. Okay, bolts, nuts and screws. So so we will move to another new topic. So another joining method, adhesive bonding. Have you heard about this one? කොහේ හරි අහලා තියෙන adhesive bonding? This is very common method in material joining. Okay. මොකද adhesive bonding කියන්නේ? So actually we are try to join two parts together. Right? We are try to hold that parts together using some methods. Now you know some weldings. We can use welding methods as example, and we can use nut and bolts, rivets. What is this adhesive? Adhesive bonding. So adhesive bonding means this is also joining method. Okay, so we can join two or more materials together using some bonding agent. Yeah, join two parts by applying glue between them. Yeah, so actually this is the bonding agent like a glue. Okay, so after applying this bonding agent, that bonding agent maybe solidifies. Then we can hold two metal part or two parts together. Right? මේක මෙහෙම අල්ලගෙන ඉන්න පුළුවන් අපිට ගම් ගාලා ඇලෙවුවට පස්සේ ටික වෙලාවක් යනකොට ඒ ගම් එක solidify වෙනවා. ගම් එක කියන්නේ bonding agent. හරි? So so this is actually important joining methods like such as welding, riveting, and bolting, nut and bolt. So හරි. ඔයාලට දැන් idea එක තියෙනවා adhesive bonding කියන්නේ ඔයාලා ගම් ගාලා මොනවා හරි පාට් දෙකක් අලවනවා වගේ. හරි? So I will say some examples. So common example actually plywood. Plywood අහලා තියෙනවනේ plywood. Okay, so plywood consists of several layers of wood. Okay, so these layers are bonded together using wood glue. Okay. හරි. මේක හොඳ එක්සාම්පල් එකක්. ඒ කියන්නේ ඔයාලා දන්නවා ප්ලයිවුඩ් හදද්දි ලේයර්ස් තමයි හදන්නේ. පස්සේ ගම් නැත්තම් ඔයාලා ග්ලූ නැත්තම් ඔයාලා කිය විදිහට බොන්ඩින් ඒජන්ට් එකක් දාලා මෙයාලා බොන්ඩ් කරනවා. එකට තියලා ලේයර්ස් බොන්ඩ් කරනවා. Okay. So final product is plywood. Okay. So we can see some advantages in this adhesive bonding. Okay. So um so we can join metal and plastic using this adhesive and provide a smooth surface finish. Okay. So actually weight reduces weight. Okay. No fasteners or welding methods we no need to apply. Okay. uh, Sometimes this type of adhesive uh, helps to resist corrosion. Right? Corrosion එක මේවා කරගන්න සමහරවිට මේ help වෙනවා මේක adhesive එක දැම්මම. So and also have some limitations. So we cannot deal with temperature. Sometimes this will impact to chemical resistance. නේ? Chemical resistance තියනවනේ ඔගේ. And surface preparations is sometimes surface preparations uh, is maybe critical. Mm, so it will take some long curing times. It will take. Okay. So some actually main problem is difficult to disassemble. Disassemble and we cannot inspect this joint. නේ අපි දැන් වෙල්ඩින් එකක් එහෙම කරොත් අපිට ඉන්ස්පෙක්ට් කරන්න පුළුවන් නේ මේක. හැබැයි සොල්වන්ට් එකක් දැම්මම ඉන්ස්පෙක්ට් කරන්න අමාරුයි. සෝරි මේ ඒජන්ට් එකක් දැම්මම මේ ඉන්ස්පෙක්ට් කරන්න අමාරුයි. හරි. Mm. So here you can see adhesives are available in various form depending on applications. So according to the applications, we can select suitable adhesive. Okay. So liquid, phase, solution, emulsion, powder, tape, film. Okay. So when I apply adhesive, typically adhesive layers are typically about 0.5 millimeter thick. Okay. So 0.5 millimeter thick එකක් තමයි අපි apply කරන්නේ නිකන් සාමාන්‍ය commonly apply කරන්නේ. හරි. So so here you can see some properties, required properties of adhesives to meet specific application requirements. Adhesive must possess one or more of the following properties. Okay. So first one is strength. You know strength mean ability to support maximum shear and peel strength without failure. Okay. So the second one is toughness. So toughness mean amount of energy required to fracture or break. Okay. So actually amount of energy required to fracture the adhesive joint. So chemical resistance, resistance to various fluid, chemicals. Um, okay. So during service. processes. Then resist to environmental degradation, including heat, moisture. So ability to withstand heat, moisture, UV radiations, and weather conditions without degradation. Okay, without degradation. Then um, capable to with the surface to be bonded. Okay, so surface. So this process ensure uh, uniform contact. Okay, so this is very important. Then we should consider these requirements, these properties. Okay, then here you can see some type of adhesives. Sorry, type of type of adhesives. So mm, mm, then it's different chemical chemically reactive structural adhesives you can see here. Okay, their properties and characteristics. um, First one, epoxy. Okay, epoxy has poor impact resistance. Tension shear is shear strength. Tension or shear strength is 15 to 22 megapascal. Field strength less than 500 23 Newton per meter. Okay. Service temperature range 55 Celsius to 120 Celsius. Okay. Then heat curve mixing requirements, solvent resistance. Solvent resistance is excellent in epoxy. Then moisture resistance good, and gap limitations. Order likewise, we can see some general properties. Okay. හරි මේ වගේ properties අනුව අපිට අපේ adhesive එක select කරන්න පුළුවන්. Okay, so here you can see different type of adhesives. Epoxy කියන්නේ මොනවද කියලා අහන්න. Epoxy කියන්නේ bonding glue එකක්. අර වගේ bonding agent එකක්. Epoxy mean bonding agent. Epoxy use වෙනවා මොනවද? ඔයාලා අර floor වලත් epoxy ගන්නවා මට මතකයි. පොළවේ පොළොවෙත් ඇපොක්සි ගානවා මොකක්ද ප්‍රොසෙස් එක කියලා මට හරියට මතක නෑ. පොළව උඩ يعني බිම මොනවා හරි අලවන්න වගේ දෙයකට තමයි එපොක්සි ගහන්නේ. වෝටර් ප්‍රූෆින් කරද්දි තමයි එපොක්සි ගාලා මොකක් හරි එකේ මෙම්බරින් එකක් අලවනවා. එතකොට ඒ එපොක්සි එතන වෙනවා ග්ලූ එකක් විදිහට තමයි එපොක්සි යන්නේ. ඒ වගේ එපොක්සි යූස් වෙනවා. හරි. So here you can see different type of adhesives, polyurethane, modified acrylic, cyanoacrylate, uh, anacrobic. Likewise, we can see. Okay. Let's see. here using this table, you can identify different properties. So, adhesives are materials used to bond surface together. You know this. Now, they can be broadly divided into three main categories based on their composition, and origin. Okay, so we can see natural adhesive, inorganic adhesive, synthetic, organic adhesives. Okay, based on origin and composition, we can categorize natural adhesive, inorganic adhesives, and synthetic organic adhesives. Okay, so natural mean ස්වභාවිකනේ. So natural adhesives we can get from using plants, animals. Okay, so some animal sources. Okay, so here you can see some examples for natural adhesives. So floor, dextrine, uh, some animal glues, animal products. Okay, so here you can see a soya flour. This is used for um, wood-based products like plywood. Right? Plywood වගේ ඒවට තමයි මේ soya flour, soya powder එක use කරන්නේ glue එකක් විදියට. Okay. So dextrine, starch, starch. This is starch mean this starch obtained from potatoes. Okay, using this is basically used in packing industry. Right? Starch කියනවා packing industry තමයි ගන්න potatoes වලින් තමයි හදන්නේ. Right? So when we come to dextrine, um, used for some envelopes. Okay, so here you can see a gummy substance obtained for starch. Okay, used for labels and envelopes. So animal glues, actually animal glues we can get from animal bones. Right? Animal bones and bones, some mm, so we can get some collagens. Okay, collagens from animals. Bones වල ඇටවලයි බොන්ස් මේවයි තියෙනේවා තමා අර සත්තුන්ගේ මේ ඒවයින් ගම් වගේක් හදනවා. Right? Collagens අරගෙන ඒ වගේ natural gum හදන ඒවා තියෙනවා. So this type of natural adhesive sometime we can get some advantages. Okay, because so natural adhesives non-toxic. Okay, biodegradable and also inexpensive. නේ මිලත් අඩුයි ඒ වගේම මේ non-toxic පරිසරයට මේ විෂ භාවය අඩුයි විෂ නැහැ. right? ඒතකොට පරිසරයට මුදා හරින්නත් පුළුවන් මොකද මේ දිදාපත් වෙන ගතිය වැඩි. And also have some limitations we can get. This is poor resistant to heat. Okay. ඉක්මනට දැන් සතෙක්ගේ මොනවා හරි ගත්තත් ඒක ඉක්මනට මේ හීට් එකට ඔරොත්තු දෙන්නේ නැහැ. ඉක්මනට පිච්චිලා මෙහා එන්න බලනවා. හරි ඒකින්ද මේක ඒ වගේ හීට් ඇප්ලිකේෂන්ස් වලට යූස් කරන්න බෑ. හරි. Then second one is inorganic adhesive. So this type of inorganic adhesive we can make from using non-organic materials. Okay, you know organic material, non-organic material. We can use non-organic material. Okay, so examples we can use sodium silicate and magnesium oxychloride. Okay, so sodium silicate is used for bonding glasses, ceramics. Okay, and refractory materials. So magnesium oxychloride used in as a heat resistant. Okay, heat resistant applications we can use for heat resistance applications and also chemical resistant applications. Okay, magnesium oxychloride. So as advantage, we can get excellent resistant to heat and chemicals. So this is actually not suitable for flexible joints. නැමෙන joint වල මේක හරියන්නේ නැහැ. හරි. Flexible වෙනේම නැමෙන වගේවට මේ joining method එක inorganic adhesive හරියන්නේ නැහැ. Then when we come to third one, synthetic organic adhesive. This produced from synthetic polymers, plastics. Synthetic polymers mean plastics. Okay, they are most commonly used modern adhesive. Okay, so we can categorize this synthetic organic adhesive as thermoplastic adhesive and thermosetting adhesive. Okay, thermoplastic adhesive soften when heated, can be remelted. This thermosetting adhesives is strong permanent bond when curd. Okay, used for structural bonding. So actually we can get thermosetting adhesive as epoxy, phenolic. Okay, likewise, and also this one also polyethylene. This one is also thermoplastic adhesive. Sorry, thermosetting adhesive. Okay. This one also becomes thermosetting adhesive. Then this synthetic organic adhesive high strength and also durable. So this may be a resistance to moisture and chemical. Okay. These have a lot of advantage. Then high is cost is very high. Some type of synthetic organic adhesive require surface preparation again. Okay, so difficult to prepare good surface. So again we need to do some activity to prepare our surface, finished surface. Then here you can see some uh, type of adhesives and adhesive systems. So here we will discuss different type of adhesives and adhesive systems. Okay, then we can see some type of adhesive and adhesive system. These adhesives are the most important in manufacturing, okay, especially load bearing or structural applications. So, so importance is provide high strength and durable bonds. Okay, commonly used in engineering and industrial assembly process, used where traditional fasteners, bolt, rivets, um, welding. Okay, these are not suitable. Then here, here first one is chemical reactive adhesive. Okay, so chemical reactive adhesive includes polyethanes, silicons, epoxies, cyanoacrylates, modified acrylics, uh, phenolics, polyamides, anobics. Okay, so um, we can see. Okay, so chemical reactive adhesives. Okay, so and so these adhesives uh, cure through a chemical reactions. Okay, so liquid to solid. So according to liquid solid conversion, this is the working principle. Okay, once cured, they form a strong, stable, and resistant bond. Okay, so high strength and rigidity, resistant to temperature, humidity, and chemical expose. Okay, one can range from flexible to rigid depending on the formulation. Then pressure sensitive adhesive PSA. So these are non-reactive adhesive. So meaning they don't need heat, water, or solvent to active. Okay. Then they form a bond simply by applying pressure to the surface. You can see here. According to this, so according to this pressure, we can mm, we can make two parts. Okay, we can bond two parts. So when pressure is applied, the adhesive flows slightly and wet the surface, creating a strong bond. Okay, so bonding occurs at room temperature, no curing or mixing required. Common in labels, stickers, some protective films. Okay, these are common applications. So commonly material used natural rubbers, um, styrene, butadiene rubber, and butyl rubber, nitrile rubber, poly polyacrylates. Okay, these are materials. So you can quickly apply this method. This is very easy method. Okay. Uh, actually, this method is good for temporary and permanent bonding. Okay. Uh, this may be depend on your application. Then so performance can be reduced at very high or low temperatures. So so as an example, you can take your masking tapes, double side tape, then some name plates, some stickers. Okay, so uh, you can get these type of examples. Okay, you can bond two compounds using double side tape. Okay, you can take a tape and you can take two parts like this. Okay, so you can apply a force here. Okay, this is a simple method. Then hot melt adhesive. So in this case, we use thermoplastic materials that melt when heated and solidify cooling. Okay, uh, they uh, they form strong bonds as they cool and hard. No, in this case, no any chemical reactions, chemical reaction involved. Okay, so here this composition made from thermoplastics uh, such as uh, ethylene vinyl, then EVA, polyolefins, polyamides, polyesters, thermoplastic elastomers. Okay, these will use. Okay, so adhesive is heated until it melts into a liquid form, then applied to one surface and pressed against another. On cooling, it solidifies quickly to create a strong bond. Okay, so this is actually soft and flexible at high temperature, and after cooling process, this will become solid. Okay, so here you can see a glue and glue stick. These are glue sticks. This is the glue gun. This is a good example for this adhesive. Here, hot melt adhesive. Okay, so becomes soft and flexible at high temperature. Then after cooling, this will become solid material. Alright. මේක දැකලා තියෙනවනේ හැමෝමනේ glue gun එකයි glue stick එකයි glue stick එක දැම්මා gun එක දැම්මා මේක මේක කරාම liquid එකක් වගේ ඇවිල්ලා නිකන් soft material එකක් එන්නේ ඒක ටිකක් වෙලා යනකොට ඝන වෙනවා solid එකක් එනවා okay so as applications used widely in industrial and product assembly. So some this type of methods used for small joint assemblies, large surface laminations, mounting mounting and trim attachments. Okay, so in some appliances, HVAC systems, we can see this type of apply this type of hot melt adhesives. Okay, so as advantage we can get this is very fast. Okay, so ideal for high speed productions and clean process, no solvents or drying time needed. Uh, some have some good strength. Okay, uh, and sometimes this type of material can be reheated and we can do reassembly process, disassembly process. Okay, I heat කරලා disassembly process එක කරන්න පුළුවන් අපිට. assemble එක අයින් කරන්න පුළුවන්. මේක පාවිච්චි කරන්න. Then another method, reactive hot melt adhesive. Okay. Then combine materials the according to the properties of thermoplastics and thermosets. Okay, they are based on uh, um, strong and durable bonds. Okay, so uh, then such as sorry, this here you can see contain a thermoset portion uh, contain a thermoset portion as a composition and nature. Then initial behave like thermoplastic when heated, later undergo a chemical reaction to form a thermoset structure. Okay, so when we come to working process, adhesive is heated before used and applied in molten form. When it cool, it hardens physically. Okay, so gaining initial or green strength. So water molecules from the air or subtract tighter chemical reaction. This reaction convert into cross-linked and giving final strength. Okay, so this is provides external heat, moisture, and chemical resistance, and is strong and flexible and permanent bond. Okay, this is very flexible and permanent bond. Okay, uh, this is very highly durable, and this type of bonding method used in automotive industry, furnitures, and in packing industry. Okay, and also textile industry. Okay, so this is suitable for bonding metals, plastics, wood, and some other compositions. Okay, some composite materials. Then reactive hot melts start as thermoplastics, but cure into thermosets, offering the best combination of flexibility, strength, and uh, stability. Okay. Then another one, evaporative or diffusion adhesive. So bonding occur by molecular diffusions and hardening as the solvent evaporate or diffuse away. Okay, the adhesive solidifies once the solvent is gone, common adhesive materials. Here you can see Winley, Winleys, acrylics, phenolics, polyethanes, synthetic rubber, and natural rubbers. Okay, these are common adhesive materials. Okay, so films and tape. Here you can see nylon epoxies, um, elastomer epoxies, nitrile phenolics, vinyl phenolics, polymers. Okay, supplied as pre-form sheet, tapes, or films. Okay, films of adhesive material. So, advantages: easy and clean to apply, uniform bonds, uh, uniform bond. So, suitable for aerospace, electronic, and laminated uh, composites. Okay. So, have some another one, electrically and thermally conductive adhesive. This is electrically and thermally conductive adhesive. So, made from epoxies, okay, silicons, polyethanes, polymers, okay. Conductivity is achieved by adding metallic fillers. Metallic fillers we can add using silver, copper, aluminum, and gold. Okay, so this is basically used in circuits, sensors, and electronic package. Okay, so used in heat sinks, electronic cooling systems as a thermal conductive adhesive. Okay, this is used as a electrical conductive adhesive and thermal conductive adhesive. Okay, so fillers are improve both electrical and thermal conductivity. Simultaneously improve both electrical and thermal conductivity. And an adhesive system may be classified on the basis of their specific chemistry. Then, actually, adhesive systems are classified based on their chemical composition and curing behavior. Okay, so here you can see some common type used in engineering and manufacturing. So, first one is epoxy-based adhesive system, provide high strength and excellent temperature resistance up to 200 Celsius. Okay, so this is of a good adhesive to metals, ceramics, and composites. Okay, so here we can see some applications, uh, automotive brake linings, bonding agent for sand mold in casting. Okay, we can use this epoxy based adhesive system. So, structural joining in machinery. Okay, this is actually high strength chemical resistant and heat resistant. Okay, so acrylic adhesive system, these adhesives are suitable for application with substrates that are not clean. So, designed for use on unclean or slightly um, contaminated surface, have fast curing and good toughness. Okay, using joint metals, plastic, and composites. Okay, so anaerobic systems. Anaerobic, this is oxygen actually prevents curing. Okay, So once placed between metal surface like thread or thread or flanges, the uh, absence of air allows rapid curing. Okay. So actually, as applications, this will suitable for thread locking. Okay. And flange gasketing, and retaining compounds. These are applications. Okay. So actually, this is very helpful for sealing, locking, and vibration resistance. This is very vibration resistance one. Okay. Then uh, this is very suitable for vibration resistance applications, locking, sealing, and vibration resistant applications. Okay. So then here you can see a cyanoacrylate adhesive. This is actually commonly used super glue. Okay. This one commonly known as super glue. Yani super glue කියලා එයා තමයි. Okay. So this is fast setting. Bonds typically from within 5 seconds, 5 to 40 seconds, 5 to 20 seconds. නේ තප්පර 5ක් වගේ යනකොට තප්පර 20ක් වගේ යනකොට මෙයා එනවන්නේ. Then produces thin, clean, and strong bond lines, and ideal for small parts and precision bonding. Okay, so actually easy to use. This type of glue, super glue, not suitable for flexible joint or high temperature environments. All done. No? Then you know about this. Then urethane adhesives. This is polyethylene. Then provide high toughness and flexibility at room temperature. Often used both adhesive and sealants. Then maintain good strength even under vibration or impact. Okay, so basically used in automotive industry. Okay, so sometime used in construction, electronics. The silicon adhesives are known as excellent um, solvent resistance. Okay, and also moisture resistance. This one silicon adhesive have impact and peel strength. Commonly used electronic sealing, glass bonding, and automotive glass, and using some gaskets. Okay, so then so combination systems, then some adhesives are blended to optimize properties. Epoxy silicons, nitrile phenolic, epoxy phenolic, then epoxy silicon combines strength with flexibility. Nitrile phenolic adds toughness and heat resistance. Epoxy phenolic increases chemical and thermal stability. Okay. Then when we consider cost, these epoxies and phenolics uh, uh, less expensive, uh, but others high cost. Okay. Then organic adhesives What are the organic adhesives? And UV cable generally begin with. Yeah, adhesives such as cyanoacrylate, epoxy, acrylic, enobic, and UV curable acrylates. Okay, generally begin to break down at temperature between 250 Celsius and 300 Celsius. So inorganic adhesives, ceramic base, thread lockers, can withstand temperature up to 650 Celsius. Okay. Silicon-based adhesive can resist temperature exceeding 350 Celsius. So most adhesive exhibit maximum shear stress at their optimum operating temperature, typically ranging from room temperature up to about 200 Celsius. Okay. So then here you can see some designing. Okay, when designing adhesive bonding, the joint configuration should ensure that the apply load act primarily in compression, tension, or shear. Okay, so you should design this. So adhesive joint should avoid loading condition, that case peeling or cleavage, as the stress can easily lead to uh, premature bond failure. Okay, so actually we should think about compression or tension or shear. Okay, is this compressive, tensile, or shear forces? We should think about these conditions. Okay, so several joint design for adhesive bondings are shown in following several figures. I will show you. So each type provides different level of strength and performance. Okay, the selection of appropriate joining design is very important and should be based on factors such as type of loading, environmental conditions, and material properties. Okay, environmental conditions mean temperature, humidity. Okay, sometimes some adhesive may be exposed to chemical reactions. Type of loadings, tensile stress, shear stress, compression stress. Okay, some bending, bendings may be here. Okay, okay. Then we should think about these cases. And here you can see poor adhesive, good and very good one. Okay, using this image, can understand how to join two parts using adhesive. Okay, so actually poor joint puts the bond is fail. Okay, so so uh, poor mean poor one, you can see here, poor one, uh, corner is very sharp, no? Then this make the load try to peel from an edge. So only a thin line carries the force. Okay. So here good one. Then these are good. These are very good. Okay. So in good one, overlap double strap layout align the path. So the glue line works mainly in shear across most of its areas. Okay, so a very good one. Uh, actually, double lap. Here you can see flange corners and area. Okay, so shape is very sharp. Okay. Then this is the very good one. Okay, and also reduce unbalanced lap. And here you can see another different methods. Okay, adhesive bonding methods. Okay, so I will wind up here. So can you share your index through chat? I will take attendance now. I already uploaded lecture notes to the VLE. You can download. Now you can download. Please go through it again. Okay. Next day we will discuss about some non-permanent fasteners, clips, rings, pins, some gears and chains. Okay, we will discuss next day. Okay, so now I will stop here. Thank you for your support.